Hi, and welcome back to the Implementing and Administering Cisco Solutions CCNA 200-301 video series course by EC Council. My name is Glenn Singh. In this video, we will take a look at describing the characteristics of network topology architectures. So let's dive on in. Network topology. What exactly is a network topology? A network topology is used to define the layout of all devices within an organization. These devices may include firewalls, routers, switches, access points, and even end devices. Network topology diagrams are usually logical, while the implementation side is physical. This means the physical topology does not always look like what is shown in the logical topology, but the connections are exactly the same. One type of topology is a star topology. In a star topology, all end devices, such as computers, servers, and printers, are all connected to a network switch. The network switch acts as a centralized network intermediary device for interconnecting all end devices. In this diagram, you can see all the PCs are connected to a network switch. If PC 1 wants to send data to another device, PC 1 sends the data to the switch will then forward the message to the actual intended recipient. Another topology is called a bus topology. This topology is where all devices are connected to a centralized or a central bus cable. If the cable is broken at any point between the server or the ground, the entire network will be down. And because of this, bus topologies are no longer being used. Another topology is a ring topology. In a ring topology, each node, whether it's a computer, is connected to two other devices to form an actual ring. In this topology, data is usually transmitted either in a unidirectional flow or in one direction. As you can see, the computers are connected in a ring topology or a ring format fashion. Another well-known topology is the hub and spoke topology. In a hub and spoke topology, all nodes are connected to a centralized device or a centralized location. This is known as the hub. For a node or a branch office to send a message to another location, it must be sent to the hub, which will then forward a message to its destination. So let's take a look at how companies interconnect their branches using a hub and spoke topology. As you can see here, the head office is acting as the hub, while each of these branch offices are considered to be spokes. If branch A wants to send data across to branch C, branch A have to send the data to the hub, which is the HQ office, and HQ will then send it down to the branch C office. Practically speaking, these links that are connecting the HQ office to the branches or the hub to the spoke are wide area network links. And as you recall, wide area or a WAN is used to extend a local area network over a large geographic distance. And speaking of LANs, here we are to discuss what exactly is a LAN. A LAN, or a local area network, is a small network which is usually existing within a small office or within a single building. On a LAN, all devices are able to share the resources with each other. A LAN usually exists in a single geographic location. An example of a very small LAN is what we call a SOHO, a small office home office. This is a small local area network, which is usually the size to cover a small building or an office space. This type of network usually involves less than 10 workers or 10 connected devices to the actual network. In this diagram, we can see a small building with just a couple of devices interconnected. This is an example of a local area network, and also a small office home office network. In certain situations, you may want to extend the resources of your local area network to another remote site that may not even be close in geographic distance. It may be very, very far away. To simply extend your local area network over a large geographic network, a WAN can be used, a wide area network. Sometimes a company wants to connect a remote office to their head office or their HQ location, such that employees are able to share resources as if they were physically or geographically located in the same location. To do this, a WAN is used to interconnect remote offices or remote sites. In this diagram, we can see location A and location B is using a WAN connection to extend the LAN of each branches. We can assume that location A is the head office or the HQ location, and branch B is a remote site. The employees at branch B may need to access the servers that are located at the HQ office, and a very simple way to get this done is to use a WAN. Now, where do you get your WAN from? Definitely, you will need to contact your internet service provider and explain what you want, and they will provide various options for WAN solutions for you. Please note that WAN connections are not internet connections. They are pretty much a layer 2 tunnel that is created between one location and another location. Therefore, this user, let's call him Bob, will be able to use his PC and access the servers that are located at the HQ location as if Bob was on the same network as the users at HQ. If we use the Cisco Enterprise architecture, we'll get many benefits. Some of these benefits will include easy scalability once our network is growing. We'll have redundancy. In the event that one path or one device is not available, the network can simply adjust the path the data is taking to reach between a source and a destination. Furthermore, we'll get improved performance from our network itself. Now, let us take a look at a 3-tier hierarchical architecture from Cisco. The 3-tier architecture consists of 3 layers: the core, the distribution, and the access layer. At the core layer, this is the high-speed backbone of the network. These switches are used to forward traffic as quickly as possible between networks which are geographically separated. So we can think of the core switches actually used to interconnect your different branch offices together. The distribution layer is responsible for providing a boundary by implementing access control lists and other types of application filters and policies. The distribution layer is usually made up of layer 3 switches. Then there's the access layer. The access layer is used to connect or interconnect end devices such as computers, printers, servers, even IP phones to the actual network. So let's take a look at Cisco website to see how these switches look. So now that we're on Cisco website, let's click on Products, Networking, and Switches. Now that we are within the product section of the Cisco switches website, we can see we have different types of switches as mentioned earlier. We have the LAN access switches. So these switches here will be used or be preferred to be implemented at the access layer of the 3-tier hierarchical structure. Then there's the distribution and core layer switches. These switches are those that will be implemented at the core and distribution layer of the actual switch network. This diagram shows all 3 layers that are interconnected. There's an access layer which connects the end devices such as PCs. There's a distribution layer which is used for link aggregation, traffic control, and filtering. There's a core layer which is used to interconnect our branches together. So you may be wondering, where did this design came from? To put simply, Cisco has a part of their website which is called a Cisco Validated Designs. Cisco Validated Designs are proof of concepts for all possible designs and implementation of technologies that you may be wondering for networking. So let's take a look at finding the Cisco Validated Design website or their URL. So let's head over to Google. And we are going to search for Cisco Validated Designs. And we will click this first website up here. And as you can see, there's a design guide for almost all possible type of implementation, whether it's security, mobility, firewalls, you name it, there's a design guide for it. But particularly, let's click on the Enterprise 3.0 Campus Architecture. This architecture simply defines the three-tier hierarchical architecture, which is a core, the access, the distribution. Coming on a little further here, we can see the same diagram. And there's a full description of the purpose and function of the access layer, the distribution layer, and even the core layer. If you go down further, you'll get a larger design based on the size of the network you may have and how to interconnect them properly. As mentioned, there are many benefits with the three-tier architecture. Improve network performance, provide better redundancy. You even get improved network scalability and improved network management. Implementing the three-tier architecture might be quite expensive, and sometimes your organization may not have enough devices to support the three-tier architecture. This means you may have a small to probably medium-sized organization. For that instance, there's a Cisco two-tier architecture. The two-tier architecture simply allows a small to medium-sized organization to gain the same benefits as the larger, much more enterprise three-tier architecture design. With the two-tier architecture, it consists of two layers. One layer known as the collapse core. The collapse core is a combination of the core and distribution layer from the three-tier architecture. And then there's the access layer. In this diagram, you can see the access layer and how it is interconnected with the collapse core. Keep in mind, the collapse core is a combination of the core and distribution layer. As technology advances, many organizations are moving to cloud providers or cloud computing. So what exactly is cloud computing, you may be asking? Cloud computing is typically allows a person to access resources or use resources on someone else's server that is perhaps located over the internet or at a different data center. Cloud computing has been a growing factor in the field of IT. A lot of businesses are actually using this type of technology to improve their daily functions and especially to reduce their annual expenditure costs. Cloud computing simply allows consumers to pay for the services they use or they need only, creating a pay-as-you-go model. If a company requires email services within their organization, senior management can purchase either Office 365 email solution or G Suite, which is from Google, but recently Google has changed it to Google Workspace. In this way, an organization does not need to have an on-prem device such as a physical server within their company doing email services. Having an on-prem device, you will need an IT department to always manage and maintain and upgrade the server. If there's no electricity, the server will go offline. This is if you have no generator or power backup solution. If there's any sort of physical components or hardware that may go faulty, your IT department will need to change it. Additionally, having physical on-prem solutions will mean that you have to pay a power utility for the power consumption and physical space is required. However, having a cloud solution, you don't have to worry about those technicalities. You don't need an IT team. You don't need physical space. and the service is always available to you as long as you have an internet connection. And with a cloud service provider, you can scale up your resources or scale down based on your usage and your needs for your organization. So what are these advantages of cloud computing? Well, the resources on a cloud computing system can be accessible at anywhere at any time. It simply reduces the physical appliances and equipment at a location, so you don't need physical space anymore. It reduces the maintenance of online platform as much as most are automatically done by the cloud solution provider. So think about you have a Windows server on the cloud from Microsoft Azure. You don't have to worry if any parts go faulty. The Microsoft Azure team will perform maintenance on their data center to ensure that all the services are running perfectly. Another advantage, as mentioned before, is to reduce the need for a dedicated IT team within an organization, simply because the maintenance is done on the cloud provider side. This brings us down to discussing the various types of cloud services. In cloud computing, there are three main types of services that are typically offered by a solution provider. These services are software as a service, platform as a service, and infrastructure as a service. So let's take a look at discussing each of these in further details. Software as a service. In a software as a service deployment model is where the cloud solution provider offers access to only the interface of the application. An example of this is Office 365 solution or Google's G Suite of applications. If you're using their email service, you'd only have access to the web interface of your inbox. You will not have access to the backend coding or the hardware that is supporting the application or even the operating system. Software as a service, this simply allows the end user such as yourself to access your email inbox and other collaboration applications simply by using a standard web browser. This solution eliminates the need for locally installed programs on your end user's computer. Platform as a service. In the platform as a service model, the cloud solution provider offers access to the operating system and possibly programming frameworks such as, let's say, programming language environment for a developer. Some examples of a platform as a service is Microsoft Windows Azure, or even Amazon's AWS Elastic Beanstalk. There's even Google App Engine. The third type of cloud service is infrastructure as a service. With infrastructure as a service, the cloud provider grants access to the actual physical hardware and software resources which are used for storage, processing power, even networking. These devices are firewalls, virtual machines, databases, storage, clusters, and so on. Some examples of infrastructure as a service platforms are Microsoft Azure, Google Cloud Computing Engine, or Google Cloud Platform, GCP. There's Amazon's AWS services. Now let's take a look at cloud delivery models. Cloud can be installed in one of four types of solutions. One type of model is a private model. In a private cloud model, the organization, as let's say your company, actually owns a data center and the infrastructure is managed locally by your team. The data center would contain software as a service, platform as a service, and even infrastructure as a service solutions, all virtualized and accessible by the employees within the organization only. This is an on-premise or an on-prem solution. Another delivery model is public. Unlike the private model, the public deployment model is available to everyone on the internet. An example of such type of deployment or such type of delivery model is the Microsoft Azure platform, the Google Cloud Compute platform, and even Amazon AWS solutions. There's a hybrid model. The hybrid model is a mixture between the private cloud and the public cloud deployment models. An organization may have their data locally backed up on their private data center, but have it replicated to an online public cloud solution provider. In this way, they are creating backup solutions and also redundancy to access services. Another example is an organization can have their local Active Directory servers or server replicated to a cloud-based Microsoft Azure platform as a redundant domain controller. Here, we can see a diagram clearly depicting or describing the hybrid cloud solution. The company has local access to their private cloud, and their private cloud is automatically backed up or replicated onto a public cloud. In the event that either cloud is not available, the company can resort to the other one. So if the public cloud is not available, the company will have access to the private cloud. If the private cloud is not available, the public cloud will have the data and the services available for the organization. The fourth and final type of cloud delivery model, the community cloud. The community is where several organizations share the resources on a cloud platform. This can be a group of companies with similar interests or partnerships, all accessing and sharing the resources amongst or even between themselves. In this video, we discussed the characteristics of various network topologies. We looked at Cisco's 2-tier and 3-tier architecture, and we even covered various cloud computing concepts and models. In the next video, we will take a look at actually getting started using the Cisco IOS. I hope this video has been informative for you, and I hope to see you in the next one.